Okay. So in the last class, we were discussing about the oscillators. So other two topics are there: LC tank circuit as well as crystal oscillator. Since it is already been done in the lab, so I am skipping that topic because you know that LC oscillator as well as the crystal oscillator. So what is the crystal oscillator means and what are the applications of crystal oscillator? So since you know that, so by that assumption I am going for the next topic so that I can finish off the second module and move into the third module. So in this third module, so after gaining an insight in the module 1 about the common, there is the BJT as well as the MOSFET biasing arrangement problem. So biasing problems, everything we have addressed. After that, we have understood about the how the BJT can be used as an amplifier as well as MOSFET can be used as an amplifier. And for that, in the second module, we started with the characterizing the amplifiers, and we have seen that common source, common gate, common drain, as well as the three frequency response. So for high frequency response as well as low frequency response, we have seen in the module 2. So after understanding that amplifier, so next we are going to see that the amplifier along with the feedback network, how the circuits is going to work. So already I mentioned, so in the last class I have mentioned for oscillator when I was discussing. So there I employed the output has been given to the feedback network, and from the feedback network it was again re-given to the input side. So based upon the type of feedback, so in that oscillators means you should assume that it is a positive feedback. That means the input signal as well as the feedback signal which is coming from the feedback network, both will be same phase. If both are same phase, that means we have seen 180-degree phase shift and 180-degree phase shift, additional 180-degree phase shift was obtained because of 3 RC sections, so that there was no phase shift around the loop. That means what? The input signal as well as the feedback signal both are in phase. So if that is the case, then that type of feedback circuit is called as a positive feedback. Suppose if the input signal as well as the feedback signal both are in opposite phase, then it is called as a negative feedback. Okay. So in the oscillator type of circuits and also you can see that so the input signal as well as feedback signal will be both are in same phase, but here both will be in opposite phase. So here we are going to discuss mainly on the negative feedback. Okay, so feedback amplifier is there, but in this content which you are going to say is negative feedback. So negative feedback is having so many advantages when compared to that of the positive feedback. So we are going to see when we are going to characterize an amplifier. So we are going to expect that the input resistance should be very high and output resistance should be very low, and the gain should be very high, the bandwidth should be very large, as well as the we can see that input and output impedance as well as the gain, bandwidth, frequency response, everything we are going to characterize the amplifier. So in that same case, if I am going to employ the feedback, so feedback we have learned. How we have learned is common source with source resistance. When you are going to add, that source resistance is going to act like a negative feedback action. So that means even though there is no direct connection from the output to input, here the negatives RSC is going to act like a source degenerative resistance, and it is the purpose of RSC is going to be a negative feedback action. So because of that negative feedback action, or because by introducing the RS in the source terminal, so we can see that the current flowing will be insensitive to the variations in the external temperature or beta variation. So that means what? That is a negative feedback by default. So that are the advantage we can get. So based upon that, we are going to learn about the what do you mean by amplifier. Already we have studied. Now we are going to learn about feedback amplifier. So for that feedback and amplifier, again there are constraints. So what is the type of the signal, and what is the type of the input signal, and what is the type of the output signal is concerned. So we know that we are going to have how many types of signals are there for your learning purpose. There are two basically. One is voltage, another one is current. So these two will be acting as an input side as well as we are going to see as the output side also same. So that means voltage or current. So based upon this combination, so we will get four types of feedback network. So depending upon the type of the input signal. Suppose if it is a voltage and voltage, then the amplifier is called as voltage amplifier. So feedback network also is going to have voltage as the input and voltage as the output. So if voltage as the input, current as the output, then what is that type of amplifier is called? Current as output, voltage as input, that is transconductance amplifier. So current as input, voltage as output, that is transresistance amplifier. Current as input, current as output, current amplifier. So for these four amplifiers, if I am going to connect from feedback network, so feedback network can be passive component. So like what we have seen RC phase shift oscillator, in its three RC sections was there. So these three RC sections was considered as a feedback network, and this feedback network, so it is going to reduce the amplitude of the signal, because whatever the amplifier, it is amplified the input signal at the output, but the output, when it is passed through the RC network, the output of the signal is going to be reduced by the feedback because of the passive components which are involved in the feedback network. So here also we are going to see, so for any system, you should have one feedback network. So it can be either in the positive form or it can be in the negative form. So that is what we are going to see. And the feedback can be either negative, so it is also called as degenerative feedback. So the other name for negative feedback is degenerative, and positive means regenerative. So positive means regeneration and negative means degeneration. So degeneration means it is going to reduce the output, whereas regeneration means it is going to increase the output. So that is what regenerative as well as degenerative feedback. So based upon that feedback, so since we know that negative as well as a positive feedback are there, so we are going to learn about the negative feedback. So negative feedback and what are the advantages of the negative feedback we are going to learn. So first thing is that, so why we are going for negative feedback? So negative feedback, so one of the advantage, so here we can see there are 5 points have written over there. So these 5 points corresponds to the advantage of the negative feedback system. So negative feedback system, so first one is desensitize the gain. So what do you mean by desensitize the gain? So the meaning of the word desensitize the gain means what? So that means when you employ a negative feedback network, so whatever the sensitivity of the amplifier is there. So we know that amplifier, we have learned, so amplifier is dependent upon the frequency response as well as the components which are present in the amplifier, which will be directly associated with the temperature as well as the beta variation, so some variation. So if there is any variation with respect to temperature, beta of the component itself or any other component which is there, so that variations will cause the variation in the amplifier gain. If it is open loop, so open loop means what? So amplifier without any feedback is called as open loop amplifier. Amplifier with feedback is called as a closed loop amplifier. Okay, so the amplifier will be having, when it is open, that is when there is no feedback, the amplifier will be very much sensitive with respect to temperature variations and anything. But when you employ a negative feedback, so more properly, so the negative feedback when you employ, then the gain of the amplifier will become constant. That means desensitized means it will not become sensitive to the variation in the external environment. So that is what the meaning of the sentence desensitize the gain. So when it will have, so whenever you employ negative feedback, it will first desensitize the gain. That means it will be not variations will not happen even if external temperature or anything it is going to have, then there will be negligible change in the gain because of the negative feedback. So desensitized means the value of the gain will become less sensitive to variations. Whether you can see the font. So this is to make sure that the gain is less sensitive to the external temperature or with respect to circuit components, or it can be caused with respect to external variations. So that means less sensitive means on employing negative feedback, it is going to become less sensitive. The circuit will become less sensitive. And the second important property of the negative feedback is reduces non-linear distortion. So reduces non-linear distortion means what? So we know that we are going to have the circuit, whatever the circuit component, whether it is a transistor, diode, anything, it is a non-linear device. So non-linear device means what? Linearity means what? For any increase in the one parameter, we have sufficient increase or decrease in the parameter means we will be calling it as a linearity. Suppose non-linear means what? If suppose input is increasing, output is reducing, that is not a linear one. Or if it is varying in an unusual way, then it is called as a non-linear behavior. Now, when you employ a negative feedback, so negative feedback reduces the non-linear distortion. Non-linearity will reduce. So that means what? It will become, the system will become more linear. So more linear. Understood? So by employing a negative feedback, the system will become more linear. So that is what the meaning, reducing the non-linear distortion. So reduces non-linear when you employ the negative feedback. So why are you laughing? ಏನಕ್ಕೆ ಅರ್ಥ ಆಗ್ತಿದೆ ಅಂತನಾ ಅಥವಾ ಅರ್ಥ ಆಗ್ತಾ ಇಲ್ಲ ಅಂತ ನಗ್ತಾ ಇದ್ದೀರಾ? ನಿಮಗೇನೆ ಸೆಕೆಂಡ್ ಬೆಂಚ್ ಫಸ್ಟ್ ಒನ್, ಸೆಕೆಂಡ್ ಬೆಂಚ್ ಸೆಕೆಂಡ್ ಒನ್ ಏನ್ರಿ? ನಾಟ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್. ನಾನು ಏನು ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ಸೊ ಫಸ್ಟ್ ಯು ಟ್ರೈ ಟು think, later I will prove that what is, how it is going to reduce us, everything I will explain. First I am just mentioning what are the important features for any circuit. When you are going to learn, so you are going to see why we are going to use, what is the advantage of using. After that, step by step we are going to see how it is going to be important, how that feature has become having importance, so that everything we will be learning in detail. So this is the non-linear distortion. So that means by employing negative feedback, the system will become more linear. So that means, in other words, the making the gain constant independent of the signal level. That means the gain as well as output as well as input will be almost constant, so that you will be having a linear behavior in the graph when you consider, when you employ a negative feedback. So third one is reduces the effect of noise. So in any communication system or any networking electronic component system, so always there will be certain noise will be added with the signal. Suppose if noise is added with the signal, it is the output will get will be not able to see the output. Whenever we see the output, there will be variations in that output. That is caused because of the noise. So it can be electrical, that is the component circuit noise, or it can be outside the noise. So outside the noise or electric circuit noise can be reduced by employing a negative feedback. So whenever you employ a negative feedback, it reduces the effect of noise. Noise, if it get reduced, means the system will become more accurate. So it is a minimum, that is the, in order to minimize the contribution of the output of unwanted electrical signal. Unwanted electrical signal or any signal which we don't want, then we will be calling it as a noise. So we have defined low pass filter or high pass filter we have seen. So after the cutoff frequency in the low pass filter, that means all the low frequency will be passing. After that, what is that? So beyond 2 kilohertz, whatever any increase in the signal frequency will have, the gain will be less, reducing. So that means what? Higher frequency are nothing but unwanted signals are nothing but my noise signal. So we don't need the higher version of the frequency greater than 2 kilohertz. So above 2 kilohertz, all my signals are considered as a noise signal. The same way here, between the electrical components, so there will be certain electrical signals which will be adding along with the normal signal. So that signal, unwanted signal, we need to eliminate. So that can be possible when you employ a negative feedback. And control the input and output impedance. So this is the fourth important parameter of the negative feedback. So controlling the input and output impedance. So suppose if we want, so the input impedance to be very much higher and output impedance should be lesser. So how the feedback network should be connected? So based upon the feedback network connection, so we can able to control the input impedance or output impedance. So we have to think. So I will show. See, till now, first and second module only amplifier we have studied. We have studied only with respect to amplifier, whether it can be common source, common gate, common drain, or common emitter, common base, or common collector, any arrangement. So it is nothing but a single stage amplifier. So for that amplifier, if I am going to employ one feedback network, so feedback is nothing but connecting from the output to the input. So that is what called as a feedback network. So there are two ways in this feedback can be connected. So there are two positive, or there are two ways. One is positive feedback and another one is negative feedback. So positive feedback is nothing but regenerative. Negative feedback is called as degenerative. So the feedback network, how it is being connected as positive or negative, I have told. If both the feedback signal, so this is nothing but a feedback signal. So this is nothing but the output of the feedback network is nothing but feedback signal. So this is input signal. If both are same phase, then it is nothing but a positive feedback. If both are opposite in phase, then it is called as a negative feedback. So depending upon that, we are going to tell that whether the given feedback is positive feedback or negative feedback. So now we are going to see. So this amplifier will be having certain input impedance, certain output impedance, R0, Rin. So when we are characterizing the amplifier, we found out what is input resistance, what is output resistance, what is output voltage, what is input voltage. After that, finding the open circuit voltage gain, overall voltage gain, circuit voltage gain, everything we have calculated. So now, for the same thing, if I employ one feedback network, again it is going to affect, right? Because feedback network is connected parallel to that of amplifier. Whether it is parallel or serial, we don't know. So if the output to the input, if I am going to connect any other network, so obviously the input impedance or the output impedance is going to get modified. So how we can modify the input and output impedance of the amplifier can be determined by the feedback network. The way in which the feedback network is connected to the input and output. So through that we can able to control the input and output impedance. So if some cases, if we require high input impedance and low output impedance means, so the value of the feedback network, how it is to be connected, we are going to see. Suppose if I want input impedance also should be higher, output impedance should also be higher. So there is another feedback how we have to connect, we should see. Suppose input impedance as well as output impedance both must be low. So if I want low input impedance as well as low output impedance, how the feedback network should be connected, everything we are going to learn. So that means by employing the negative feedback, so we can able to control the input and output impedance. So that is about the fourth important point. So fifth one is extend the bandwidth of the amplifier. So bandwidth of the amplifier, we have seen. What is bandwidth of the amplifier? So bandwidth means what? Bandwidth means what? So this is what the bandwidth of the amplifier. So this is the amplifier. So this is having mid-band gain and high frequency gain, low frequency response of the amplifier. So this corresponds to the bandwidth. That means what? Any change in the frequency, you can see the gain is going to be constant. So this is what we expect for any amplifier. That means over the various range of the frequency, so the amplifier should not vary too much. So that means you should get the constant gain. So the bandwidth of the see, this is first amplifier response for see, that's what first module, second module and third module. So all are interlinked. So if you understand certain things, then only you can go for the next topic. You will understand. Otherwise, I will be telling, but you will be not understanding anything. So this is the bandwidth. We have found out, right? So Fh minus Fl will be considered as the bandwidth. Normally Fl will be very less, so bandwidth will be corresponding to Fh itself. But code में तो explain नहीं देते हैं. FH minus FL. Normally, FL will be very low frequency. That means here the frequency will be in terms of 0 to 10 kilohertz. Maximum will be FL will be 0 to 10 kilohertz. So if it is 1 megahertz, so I have told, right? So 1 megahertz minus 1 kilohertz means 10 kilohertz means what? 990 kilohertz. That means it is approximately equal to 1 megahertz. And the end. So that corresponds to what? That is nothing but the upper cutoff frequency. That is what the bandwidth. So bandwidth is nothing but fH minus fL. So that is nothing but the bandwidth. So the bandwidth, higher the bandwidth, the response of the frequency of amplifier. So how the amplifier contact. So we have to see that the bandwidth is very large. That means for any signal frequency of our interest, we should get maximum gain. Because here you can see from this frequency to this frequency, so there is maximum gain you are going to get. So that is what is expected for any amplifier. So feedback amplifier increases the bandwidth of the amplifier. So that is extend the bandwidth of the amplifier. Extend the bandwidth of the amplifier. So here whatever the amplifier is there, open loop amplifier. Suppose if the bandwidth is 1 megahertz, upon employing the feedback network, the bandwidth may increase to 10 megahertz. That means the extension of the bandwidth is going to happen. So only drawback when you connect the negative feedback amplifier is it is going to reduce the gain. Reduces the gain. This is the only drawback which you are going to find in the negative feedback. Reduces the gain when compared to the open loop amplifier. So you have to compare. So whatever the parameters I told, you have to compare. Open, what is the open ideal characteristics of open? What is the other is the next. So what are the ideal characteristics of open? I will tell you. K. Santosh Kumar. Open operational amplifier. So that's what any amplifier will be having certain ideal characteristics. So that is what ideal characteristics of open I am asking. Yes. Everything I am only doing now, so let it be this also I will only tell. There is no difference at all. Nothing more than effort exam so daily see what is the difference between faculty and students is for you only all 4 months put together one exam is there, that is not orally written writing. But for entering into the class, we have to be prepared for the class and we have to deliver. Daily is an exam for us. See, whatever I will write on the board cannot be explained by everyone. Correct? Board will complete and the book board will complete. Without knowing the concept, if I write, can I able to explain all the things? Board will complete I am looking at the board and explaining everything from the board by reading newspaper again. Certain things if it is having difficulty if you are facing, so what you people are doing from your side, effort. Now subject is AEC signal processing so what you have to do? So you have to put more effort. This subject people are DS game. ಆ DAC ಕಂಪ್ಯೂಟರ್ ತುಂಬಾ ಆರಾಮಾಗಿ ಬರೀತಾರೆ ಕೇಳಲ್ವಾ 1 0 flip flop latch synchronous asynchronous that is combination circuit sequential circuit over how to make KMF how to simplify my expression sum of product or product of sum not student break result circuit and ಆರಾಮ ಮಾಡ್ಕೊಂಡು ಹೋಗೋದು see for that you have to put effort but you have to put more effort for this subject right basics illa see that is not your mistake also that is not my mistake also ನನಗೆ ಈ ಸಬ್ಜೆಕ್ಟ್ ಮಾಡಬೇಕು ಅಂತ ಹೇಳ್ತಾರೆ ಬಟ್ ಪ್ರೀವಿಯಸ್ ಸಬ್ಜೆಕ್ಟ್ ಮಾಡೋದೇ ಏನಿಲ್ಲ ಬೇಸಿಕ್ ಎಲ್ಲ ಹೇಳುವಂತ ಏನಿಲ್ಲ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಅನ್ನೋದನ್ನ ವಾಟ್ ಆರ್ ದ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಐಡಿಯಲ್ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಗೊತ್ತಿಲ್ಲ ಸೊ ಇನ್ಪುಟ್ ಇಂಪಿಡೆನ್ಸ್ ಇನ್ಫೈನೈಟ್ ಇನ್ಪುಟ್ ಇಂಪಿಡೆನ್ಸ್ ಕರೆಕ್ಟಾ ನೆನ್ಪಂದ ಬರಲಿಲ್ಲ ಝೀರೋ ಔಟ್ಪುಟ್ ಇಂಪಿಡೆನ್ಸ್ ನೆನ್ಪಂದ ಇಲ್ಲ ಇನ್ಫೈನೈಟ್ ಗೇನ್ ನೆನ್ಪಂದ infinite bandwidth, slew rate, power supply rejection ratio, CMR, common mode rejection ratio. ಇದೆಲ್ಲ ಕೇಳಿದ್ರೋ ಇಲ್ವೋ ಲ್ಯಾಬ್ ಅಲ್ಲಿ ಮಾಡಿಲ್ವಾ Okay, come to the topic. So this is what the extension of the bandwidth. So this is 100% question. 100% question. If they ask for 4 marks, you have to write these 5 steps. What are the important properties of negative feedback? So first property, important property is what? Desensitizing the gain. Second one is reduces the non-linearity. Third one is control the input and output impedance. Reduce the effect of noise. Fourth one is control the input and output impedance. Fifth one is extend the bandwidth. So 5 steps with explanation. If you write, then 4 marks is there in your hand. So feedback, first question definitely they will ask this one. Suppose if they don't ask this, so next step is we are going to learn about the general feedback structure. So what is general feedback structure? So the amplifier and feedback network will be there. So one is the amplifier, another network which is connected from the output to input is the. So this is the general block diagram of the feedback structure. So first one is what? Input signal source. So voltage signal source connect ಮಾಡ್ತಿದ್ದಾನೆ control. Suppose common source andre so V signal anta connect ಮಾಡ್ತಿದೆ. So what is that? Signal source. So here also that is only same source. That is next is what? ಏನದು? Summer circuit. So in this summer circuit it is going to take the sum between the XS and XF. If both are same phase, then it is positive feedback. Correct alva? So XS is positive, XF is negative. That indicates what? It is a negative feedback and the. Correct and wrong. ಎರಡು same phase, it is phase shift around the loop should be equal to 0 on the ಬೆಳಗ್ಗೆ. So that means what? Input as well as the feedback both are in phase. If it is same phase, that means it is a positive feedback. So here input is XS, XF is output of the feedback. So both are getting subtracted. Means what? It is opposite phase with respect to signal source. So XS minus XF will be having XI. XI is what? The input or error signal. Error signal means XI will be equal to XS minus XF. So that is XI. XI is input to the amplifier. So that is acting as input to the amplifier input. So amplifier can be any one. Common source, common gate or common drain, common emitter, common base or common collector. So any of the configuration, so you can use as an amplifier. It is having a gain of what? A. A corresponds to amplifier gain. And Xi is input, and when The input is appearing at the input, the output will be x naught. X naught will be equal to what? Xi multiply with the gain A. So that gives the output of the amplifier as x naught. So this x naught will be connected to the load. So load can be the actual load or it can be input impedance of the succeeding amplifier stage. So this is load. So now you are going to connect one feedback network. So this feedback network is having a gain of what? Beta. So this beta corresponds to feedback gain. So x naught is the output of the amplifier. That output is acting as an input to the feedback network. So for this feedback network, x naught is input. So x naught multiply with beta, so that gives the output, that is xf. Xf corresponds to what? Feedback of the output signal. So feedback network in the output is nothing but xf. Xf is equal to what? X naught multiply with beta, that is xf. So this xf is getting subtracted with the xs to produce the xi. So in this way, the general feedback structure of the negative feedback is being given. Suppose if it is plus, then it will be the same feedback structure. We are going to call it as what? Positive feedback, not negative feedback. So here you can see general feedback structure of the feedback amplifier. So this is how the signal flow and the quantities are measured. So now you consider, based upon the signal flow structure, you can see. So what is output of the amplifier? Output is given x naught. X naught will be equal to what? A multiply with xi. Correct? So next one is feedback output. What is the feedback output? Xf is equal to beta times of x naught. So that is equation 5.2. That is xf is equal to beta times of x naught. So next one is what? xi. So xi is the signal which is nothing but xs minus xf. So this is signal source and this is feedback signal. Both are getting subtracted and this is the error signal. So we are going to call. So feedback signal xf is subtracted from the signal source xs, which is then given as input to the amplifier. So xi is the also called as error amplifier signal. So whenever it is being done, so we need to find out the gain of the amplifier. So why we need to find the gain of the amplifier? Because this amplifier gain we know, but since we have connected the feedback network, so now the gain becomes the loop. So it is called as closed loop. Now we are going to call it as closed loop gain or negative feedback gain. So if feedback network is not there, so if this circuit is not there, then it is called as open loop. If feedback network is connected, then the signal will become closed. So closed loop. So whenever feedback network is connected, then you are going to get certain gain, that is called as feedback gain. So beginning morning class we have written A into beta. So that is what? The loop gain. So this is what the loop gain, A into beta. We need to find. So the gain which you are going to get with respect to feedback, we will be calling as AF. So what is x naught? X naught will be equal to what? A times of xi. Xf will be equal to beta times of x naught. Xi is equal to xs minus xf. So now we need to find the loop gain, that is feedback gain AF. So AF is equal to what? What is that? XF minus XF by feedback gain X naught by. So that means for this now feedback network is attached. So output signal by input signal source, that is nothing but the feedback. So the gain with feedback we are going to call it as AF. If it is not mentioned, then what is that gain? Open loop gain. Now we are going to have AF. So what is this? X0 is nothing but the output signal. So X0 is equal to what? A times of Xi. Xs is equal to what? So here the term Xs is there. Xi minus or plus of plus Xf. What is this Xf? Beta times of X0. What is X0? A times of Xi. So AF, negative feedback gain, AF will be equal to what? 1 over so what is this? A corresponds to what? X0 by Xs is the remote amplifier. Without feedback, whatever the gain we are going to get, that we are going to mention it as open loop gain. So A corresponds to open loop gain. So this is closed loop gain. So open loop gain over 1 plus A into beta, because we are connecting this one. So we are going to get this as the gain. So from this, what you are going to conclude? Negative feedback it is a normal gain. So always A to beta will be greater. Okay, correct term. A is nothing but open loop gain. Open loop gain of op-amp is what? 10 power 7. Open loop gain. But if we employ non-inverting configuration, inverting configuration or voltage follower configuration, so in voltage follower, so the gain will become unity. But in non-inverting amplifier, 1 plus RF by R1. In inverting RF by R1. So this corresponds to what? This is negative configuration. So whether it is a non-inverting or inverting or voltage follower, the gain is very less. Correct? When compared to open loop gain of op-amp is 10 power 7 or greater than or equal to 10 power 7. 10 power 7 is just there. But when you see this is in the closed loop form, whether it is a voltage follower or it is a non-inverting or inverting, so you will be having the gain is going to be controlled by the external feedback. So this is the feedback components. So this feedback components is going to reduce the gain of the op-amp. The same way, negative feedback has reduced the open loop amplifier gain by a factor of 1 plus A into beta. So normally, if you consider, so A is there, A into beta will be usually greater than 1. So we can easily neglect this. So we will be having what? A into beta. So this will get cancelled. So negative feedback gain, if you consider, it will be 1 over beta. That means it is going to have the gain reduced by a factor of 1 over beta. Less to beta gain is there, first to main amplifier gain will get reduced. So now what you can tell? Closed loop gain will always be less than the open loop gain. That means in one of the property we have mentioned, right? What is one of the property? but the gain is going to reduce. So this is what one disadvantage we are going to see in the case of negative feedback. The gain will get reduced by a factor of 1 over beta. So that is what here you can see. So this is the closed loop gain A over 1 plus A beta. Okay, so with this I'll just conclude today. So tomorrow will be